Have you ever pondered why we can't reach absolute zero, a temperature of perfect stillness where all motion comes to a halt? The answer lies in the intriguing realm of the third law of thermodynamics. The third law of thermodynamics, much like its predecessors, governs the behavior of our universe. It's a fundamental principle of nature, as important as gravity or the speed of light. To understand this law, we must first grasp the concept of entropy. Entropy is a measure of disorder or randomness in a system. Imagine a box of puzzle pieces. If the pieces are scattered randomly, the entropy is high. But if the puzzle is assembled, the entropy is low. Now imagine a perfect crystal at absolute zero, a hypothetical temperature at which all motion stops. According to the third law of thermodynamics, such a perfect crystal would have zero entropy because it's in a state of perfect order. But here's the catch. Reaching absolute zero is impossible. Why? Because to remove all heat from a substance, we would need an infinite amount of time. This leads us to the Nernst heat theorem, an alternative statement of the third law. It tells us that as temperature approaches absolute zero, the entropy of a system approaches a constant minimum. In other words, while we can't reach absolute zero, we can get increasingly closer to it. The entropy decreases, but it never quite reaches zero. This is the reason why we can't achieve a state of perfect order, or zero entropy. So, to summarize the key points of the third law of thermodynamics. First, it states that the entropy of a perfect crystal at absolute zero is zero. This represents an ideal state of order. Second, it introduces the concept of absolute zero, a temperature at which all motion stops. However, it also declares that absolute zero is unreachable. Third, it gives us the Nernst heat theorem, which states that as temperature approaches absolute zero, entropy approaches a constant minimum. The third law of thermodynamics presents a fascinating glimpse into the nature of our universe. It tells us about the inherent limitations of our world and the elusive quest for perfect order. It's a testament to the beauty of science, where even the impossible has a logical explanation.